Welcome back. We are now going to look at the second part of the exponent laws notes. We are now on the quotient of powers property, which states when you divide exponents by the same base, you can subtract the exponents. So we are going to look at, again, why this works. So instead of having a as the exponent and b as the exponent on n, let's give this some numbers. If we said n to the third divided by n to the second, right? If we wanted to expand this out, n to the third is really saying n times n times n, and this is divided by n squared, which is n times n. Well, because these are all the same base, we know that a number divided by itself is 1, so it cancels itself out, so these would cancel out and these would cancel out, and you would just be left with n, or n to the first power, right? N to the first power is n. So we look at that a minus b, so 3 minus 2 would give us that 1. Likewise, if we did this again, instead we said maybe n to the third divided by n to the fifth. Again, if we expanded this out, this would say n times n times n divided by n times n times n times n times n. Again, we can cancel out these because when we divide them by a number by itself, you would get 1. So really, if you have 1 all in the numerator, you're just left with 1. And then you're left with n times n in the denominator, which is n squared. So if we looked at that, 3 minus 5 would give us negative 2. So that would really be n to the negative second. And when we go back to our negative exponent laws, we know that we could also write this as 1 over n squared. So that's why the quotient of powers property works. So when we look at these examples, b to the 8th divided by b to the 3rd would be the same thing as b to the 8 minus 3. So that would be b to the 5th. When we have our coefficients, again, just like we did with the product of powers property, we can divide our coefficients like we would normally. So 4 divided by 2 would be 2. And then we can work with b. So then we'd have b to the 9th divided by b to the 4th. So 9 minus 4 is 5. So that would give us b to the 5th power. For number 3, again, we can look at our coefficients. So we have 12 divided by 6. 12 divided by 6 gives us 2. And then we have y to the 5th divided by y to the 3rd, which would give us y to the 2nd. All right, the last one, we have 15 divided by 3, which will give us 5. And then we have x to the 2nd and x divided by x to the 4th. So 2 minus 4, right, would give us x to the negative 2nd. And again, because we do not want a negative exponent in our answer, we need to rewrite it. If we think back to our coefficient, right, our coefficients always have the exponent of 1. So 5 does not move. 5 will stay in the numerator. But now x to the negative 2nd will go to our denominator. So we have 5 over x squared. All right, the last property we are going to look at is the power of a power property. Very similar to product of a power, except for this is when you would have a power also that you are multiplying. So you do have an example here that you can look at when it says x squared to the 3rd power, right? X squared is kind of your base here. So this is telling you to multiply x squared 3 times. So x squared times x squared times x squared. If you simplify out each of these x squareds, it's saying x times x, and then multiplied by another x times x, multiplied by another x times x. So in reality, you have 6 x's, which is x to the 6th. So anytime we have a number multiplied, or a power multiplied by a number with another power, you're really multiplying the two powers together. That will go for anything on the inside of your parentheses. So if you had, sorry about that, if you had a coefficient and then a number to the power, this outside power still gets distributed to all of the numbers on the inside of the parentheses. Same thing if you had the division. So let's look at what that would be like. If we again have b to the fifth, that's saying b to the fifth times b to the fifth, which would really be b to the 10th. Okay. Y squared, this is saying y squared times y squared times y squared, which again is really y to the 6th power, because 2 times 3 is 6. If we look at the third example, the exponent on each of these is really 1. So this is really saying 6 to the first, x to the first, and y to the first. Right? So we're really just distributing that 2 to each one of those exponents. So this is saying 6 to the first twice, so 6 times 6, x to the first twice, x times x, and y to the first twice, y times y. So you're really getting 6 squared x squared times y squared. And then you can evaluate that 6 squared, so you have 36x squared y squared. Okay. Here, again, you have 3, that's really 3 to the first power. So this is really saying 3 times x squared times y squared 3 times, right? So I'll just show you what that looks like. That's saying 3 times x squared times y squared times another 3 times x squared times y squared times another 3 times x squared times y squared, right? So you really have 3 to the third power. So that's 1 times 3, which is 3. And then you really have x times x times another x times x times another x times x, which is 6, which is really 3 times 2, which gives us x to the 6th. And the same thing for y squared, and another, oops, that should be a squared, y squared, which also gives us 3 times 2, which is y to the 6th. Because we can evaluate this 3 cubed, we will, and we'll get a final answer of 27 x to the 6th, y to the 6th. Let's look at the last two examples. Again, even with division, this squared is being applied to every number on the inside of the parentheses. Don't forget that that coefficient has an exponent of 1. I always like to put that there so I remember. So we really want to say, right, 4 squared. And then we have a squared twice, which is really 2 times 2, a to the 4th. And then we have b to the first twice, so that's b squared. And then c cubed squared, so that's 3 times 2, which gives us c to the 6th power. That was only our numerator. We now have our denominator. So we have a, again, that's a power of 1, so 1 times 2, it's just a squared. And then c squared to the 2nd power, which is going to give us c to the 4th power. Because we can have this is a 4, we can actually square it. So instead of having 4 squared, let's just make this a 16. So we have 16 here, and now we can work with the same bases. So we have a to the 4th and a squared we can work with, and then we can also do c to the 6th and c to the 4th. Because there's no other b, we will not work with that b. It's going to be by itself. So we're left with 16. And then a to the 4th divided by a squared leaves us with a squared. We're left with b squared. And then c to the 6th divided by c to the 4th. Again, 6 minus 4 is 2. So c to the second. So our final answer would be 16a squared b squared c squared. Right, the last one we are going to look at is number 6. Here we're going to work with this power of a power first. So we again know that this is really a 2 to the first and a to the first, right? So we can distribute that 3 through. So this is really saying 2 to the third power, which is 2 times 2 times 2 gives us 8. A to the first to the third, which gives us a to the third, and then b to the sixth. And then that's multiplied by 5a to the fifth b. And now we can do the product of powers. So we have our coefficients we want to multiply. So we have 8 times 5, which gives us 40. So we're left with 40. And then a to the third times a to the fifth would give us a to the eighth. And b to the sixth, and don't forget, remember, this is a power of 1, so that's b to the first, which leaves us with b to the seventh. So our final answer would be 40, a to the eighth, b to the seventh. This concludes our notes on exponent laws. After you stop this video, please do the practice problems with your notes. Thank you.